Well, let us consider a question which is coming from University of Cambridge International Examinations, that is General Certificate of Education, Advanced Subsidiary Level, Paper 2, Pro Mathematics 2, which was taken May-June 2011. The paper's code is 9709/21. So it's question 1, and question 1 reads, solve the equation 3x plus 4, and we have these signs enclosing the expressions, the terms. So this signs means the absolute. We consider the absolute values. Considering absolute values simply means that we are not interested in direction, but we are interested in the magnitude. Now the same applies to this end. So this is an equation, but to what point do we call it an inequality? So in solving this, first it will be necessary for us to square each term, then equate. By squaring, then we shall have observed the condition that the condition of absoluteness. So let's move ahead and see how we are to navigate through this to score the 3 marks. Well, we need to look at this. Now the topic that we have is inequalities. Let's call it inequalities. And I want us to first understand what we mean by inequalities and why we have to meet it in our attempts to make meaning out of some real scenarios in life. Now, an inequality simply is an equation that would actually, it's not an equation, it's a relationship that describes it's actually an equation would relate to different equations. But in the event where we have those two expressions not being equal, it is necessary to give it the sign less than or greater than. And in that case, then we refer to inequality, because we don't expect the two expressions to be equal. So for instance, the expressions that I'm referring to would be something like, say, 3x plus 4 is equal to 2x plus 5. 2x plus 5. 2x plus 5. Now, what we see here is that we see these two signs which refer to absolute. And whenever we bring in the aspect of absolute, we are simply saying we are not interested in direction. So because if we are saying the absolute of this is equal to the absolute of that, but we know that on a number line or in practical cases where we are dealing with, say, temperature of body of a human being, or say temperature of a metal measured over time in a particular experiment, we'll see that we'll be recording values. If it's temperature, then our recordings will be centered around the freezing point that is defined. And if at all we are referring to distance, because it is possible that I've stationed myself in a particular point. Now I want to move, say, 5 steps ahead. I can move 5 steps ahead or 5 steps behind. In that case, the direction is not important, but the magnitude. So that is what brings us here. And that's exactly why we meet such kind of equations or expressions in mathematics, because there are instances where we are not interested in direction, but we are just interested in change. Another way of finding this, you may find situations where you are told that instead of us saying is equal to, we may say greater than, that this expression is greater than that. Those are scenarios that we can get. So let's try to explore what we have with the original example that I've given, which is this equal to that. And we'll see again why I call it an inequality while we have this particular equal sign in between them. So just like I said, if you imagine yourself tracking your distance from a starting point, say you're moving from, say, a starting point, which is the origin. So you could move, say, let's call this one step. So we have 1, 2, 3, 4. Or you could move -1, -2, -3, -4. Now, realize that I'm talking about negative, negative, negative. While in real sense, that negative, the negative that I'm referring to has no meaning when I'm referring to direction, because direction is not going to be negative. But there are instances where taking account of the negative aspect or the direction of the movement is useful. So suppose I start here. I can move 4 units this end, or I could move 4 units the other end. In which case I shall have moved 4 units. But now, what makes the difference in sign is the direction. But now, there are situations where that direction is not what we pay attention to. So that's that. That's exactly why we have this. Then if you have, say, this and this, how would you make them equal? How would you make them equal? If you have, say, this and this, how would you make them equal if you are asked to find a way of making this equal to this? But I've said that if you are observing the signs, then that may not be the case. But if you are just considering the absolute, then if you're just considering the absolute, then you'll still see that then it is possible to say, actually this equal sign here exists because we are now talking about the absolutes. But let's see, by the time we draw, we shall have seen how these curves flow so that we see what lies where. But my first attempt in trying to solve this, having seen why we meet such kind of equations in mathematics, now this is an example that I want us to consider before we consider some further examples, and possibly we look at an example, which is similar to this. So solution here, this is how I would go about it. I would first try to square this side and square that side. Squaring here has the effect of eliminating the negatives, and that then makes it conform to the condition of absolutes. So I would first say 3x plus 4 times 3x plus 4. That would give me this by this. When we are expanding two expressions, then we first take this by this, and that gives us 9x squared. And then this by this, which gives us plus 12x. Plus 12x. Then this by this, plus 12x. Then this by this, plus 16. Plus 16. So what we have by squaring this, is we have 9x squared plus 24 x plus 16. Plus 16. Now that is this part. That is now this part. I've squared this, and that's what I get here. So it means that wherever there is this, I can then substitute this. But then let me see what we have by expanding 2x plus 5. So 2x plus 5 times 2x plus 5 will be, we do the same thing that we did here. That's what we do. So it will be this by this, which is 4x squared plus this by this, which is 10x plus 10x. It's 10x because it's this by, okay, this times this gives me this, then this by this gives me 10x, then this by this will also give me another 10x, then plus this by this, which is 25. So in this sense, this is just 4x squared plus 20x plus 25, plus 20x plus 25. So that's what we have. Then I equate this to this, because exactly that's what has been done here. So equating them will then mean that I have, I wanted to, well, I can bring it here so that I condense it there once I'm done. So we see clearly that if you have 9x squared plus 24x plus 16, where all this is this, then we say is equal to this, which is now 4x squared. I should have had a situation where it continues, but while I can just overlap, we see how we are moving. So I'll just say 4x squared plus 20x plus 25 plus 25. Then we see that this is 9x squared, this is 4x squared. So we can bring the 4x squared this end. So 9x squared minus 4x squared, that should give us 5x squared. And that is so because when this crosses this equal sign, it becomes a negative. And so I'll be having 5x squared. Yes. Then again, I have 24x and 20x. This 20x should cross this equal sign, and so it becomes minus 20x. So it's 24x minus 20x, giving me plus 4x. Again, I have 25, which if it crosses, it becomes minus 25. So I'll be having 16 minus 25, which is minus 9. And I say that is equal to 0. So having that, if we followed up to here, now I will wrap this part, and now I consider the condensed version, because all the information that there is here, we have already brought it here. So by dealing with just this particular quadratic equation, we shall have dealt with all the characteristics found in both. So yeah, if there is a question you ask, because I wanted us to go step by step, and up to here, if there is anything that you have not, a point that you feel we should not pass, you raise it now. So here, I now have this. So I would say, in fact, I don't even need the upper one. Yeah, this one, I don't even need it too. Now I don't need it. Yes, yeah. So that's okay. So I'll say 5x squared plus 4x minus 9 is equal to 0. I want to solve this quadratic equation so that I get the possible values of x. Because if I get the possible values of x, then it means that at those particular points, we are going to get the roots of x. So, two values whose product is negative 45 because the coefficient of this and the c constant, if you multiply them, you get negative 45. But we also want that those two factors, if we add them, those two numbers, if we add them, we should get 4. So 45, we can get 45 by multiplying 9 by 5. So I will come here and say 5x squared plus 9x minus 5x minus 9 is equal to 0. Because if I do this, it's just a way of rewriting the upper one, because 9x minus 5x is still 4x. But so I've just found a way of rewriting. But because I want to factorize these numbers, these terms, what then I'll do is to bring them, to make them look like, say, 5x squared minus 5x plus 9x minus 9 is equal to 0. So I can factorize 5x so that I have x minus 1 plus 9 into x minus 1. So what I have here then is 5x plus 9 in bracket x minus 1 should be equal to 0. So here, what it means is that it's either this term is equal to 0 or this is equal to 0. And that's why we are going to have two roots. So if I make x the subject here, it then implies that my x is going to be 1, because x minus 1 is equal to 0. So x is 1. Or another value of x will be 5x plus 9 is equal to 0. If I make x the subject, it will be minus 9 over 5. So these are the two roots that we find. The two roots that we find that we were looking for are at the point where x is 1 and x is equals to minus 9 over 5. So up to there, the next thing that we need to do is to plot. And plotting, we plot so that we see how it looks, so that we see how the curve moves. And after seeing how the curve moves, then we are able to read off these values from that particular curve. Now, for that part, I would show you how to draw. Like if you consider, if you express the quadratic equation in terms of y is equal to 5x squared plus 4x minus 9, then we can generate the values of xy. We can generate the values of xy so that when x is 0, definitely what will y be? When we say x is 0, then we put 0 here, 0 here, it will be minus 9, like that. And when y is 0, what will x be? So we will substitute, and that is what gives us the roots. So it's going to be 1, or again it's going to be, because we add that, it's going to be this. But I'm going to use a software so that we see how this curve looks. And the reason why I've chosen to use a software is it will be possible for me to mimic different scenarios in terms of changing the values, the coefficients of x. So from here, I want us to see the graphical part of this equation, or in other words, what I want to do is to visualize this diagram so that you see how it flows, and you also make meaning out of x is equal to 1 and x is equal to -9. So for that, follow me. Now we see how our curve looks like, because now we want to observe the physical form of the curve. We want to visualize. We take it from the equation that we had to a graphing that we can observe so that we study its features. So we had 5. I would just come here so that you can see what I'm doing. So I would choose 5 here, then x squared plus 4x, and it's -9. So we don't put the is equal to 0 term, because when we have that being equal to 0, it means we have already conditioned the value of y to 0. But now, because we want a curve where we allow y to take up different values, then we just draw 5x squared plus 4x minus 9 as such. And then if you look at this curve, if you study this curve now, you'll see that by bringing it much closer, you realize that at this point, where the function 5x squared plus 4x minus 9, this cuts the x-axis, that's where we find the roots of the equation, of the quadratic equation, which we worked out on the board. And you see that we had one value to be x equal to 1, and the other value we had to be -9/5. -9/5, that is 1.89, something close to 2. So you see that this particular point here, this is the point, the other value, you see it's a negative. Yeah. So that's what we have. So we have the two roots, you can see the two roots. And if you look at this curve, you see that it appears to be having a minima at this point. This point we appear to be having a minima. Yes, from a distance it looks like it's 10, but it's not 10, it's close to 10. It's close to 10. So that at that point, approximately -9.8, that's a minima. And that is what describes this curve. And these are characteristics, these are characteristic or feature of curves where we have the equations that define them, like the ones we had here. The equations that define them, like the ones we had here, 5x squared plus 4x minus 9. You see that the coefficient of this term here is 5. It is positive. And straight away, by looking at this, we already know that our curve is going to be U-shaped as this. So that wraps up my response to that particular question, and we meet next time.